In this video, I'm going to go over how to solve the mole practice problems. For the first part of this worksheet, it asks us to find the molecular weights, also known as the molar mass, of each of the following compounds. So all we have to do is add up the masses of each of the elements in the compound. So for instance, for this first one, sodium hydroxide, we find the mass of sodium, 22.99, plus the mass of oxygen, 16.00, plus the mass of hydrogen, 1.008. And we take our trusty calculator, and we get that the answer is 39.998, or we can just round that off to 40.00. We're going to just round everything off to 2 decimal places. For H2O, hydrogen's 1.008. Now we've got 2 hydrogens, so we're going to need to multiply that by 2, so we get each of the hydrogens in there, plus the mass of oxygen, 16.00, and that's going to equal 18.02. Now the units for all of these, if we want to put some units with these, are grams per mole, because that is the number of grams in 1 mole. For this third one, H3PO4, we take the mass of hydrogen times 3 plus the mass of phosphorus, 30.97, plus the mass of oxygen, 16 times 4. Excuse me. And that's going to equal 97.99. grams per mole. And for number 4, we'll take the mass of manganese, 54.94, times 2, plus the mass of selenium, 78.96, times 7. So 54.94 times 2 plus 78.96 times 7. That equals 662.6 grams per mole. Now, for the rest of these problems, I'm going to work them out on a separate page so I have enough room to work. Problem number 5 says how many grams are in 0.02 moles of beryllium iodide. So I'm going to start by writing down what we're given. 0.02 moles of BeI2. And in this problem, we're trying to go from moles to grams. Now there's a relationship. We have particles, we have moles, and we have grams. The relationship between moles and grams is the molar mass off the periodic table, and the relationship between particles and moles is Avogadro's number, 6.022 times 10 to the 23rd power. In this case, we're trying to go from moles to grams. So we're just doing a single step conversion. So in this problem, we're going to set up a little conversion factor. On the bottom, we're going to put the units of moles, because we need our units of moles to cancel out. If we have moles on top and moles on the bottom, moles divided by moles cancels out, just like anything divided by itself goes away. It's a basic algebra rule. And we're trying to find grams. Now the relationship is that 1 mole of beryllium iodide equals the mass of beryllium, 9.012, plus the mass of iodine, 126.90, times 2, because there's 2 iodines. Take 9.012 plus 126.90 times 2, and that's 262.81. So up here I'll put 262.81. So now, to actually solve this in our calculator, we're going to put 0.02 times 262.81 divided by 1 equals 5.2562. And as I said, we're just going to round to 2 decimal places for all the problems. That's going to be 5.26 grams. Problem number 6 says how many moles are in 68 grams of copper 2 hydroxide, CuOH2. So in this problem, we're going to start with what we're given. 68 grams of Cu parentheses OH close parentheses 2. Now in this problem, we're trying to go from grams to moles. It's like the first problem number 5, just going the opposite direction. So we started with grams. Our unit of grams will go in the denominator of our conversion factor. And what we're trying to find goes in the top, moles. And once again, 1 mole equals the mass of all of these elements added together. So we'll take the mass of copper, which is 63.55, plus the mass of oxygen. Now we've got 2 oxygens here, so times 2, plus the mass of hydrogen, 1.008, also times 2. And that's 97.566, 97.57 grams. We'll call that 97.57. Now we just put this in our calculator. 68 times 1 divided by 97.57 equals 0.6969355,335. So we're just going to round that to 2 decimal places. We'll call that that'll round off to 0.70 moles of copper 2 hydroxide. Problem number 7 says how many grams are in 3.3 moles of potassium sulfide. So these problems all seem to be working along the same basic way. This is going to be just like problem number 5. We're starting with 3.3 moles of K2S, and we're trying to find grams. So in our conversion, moles will go on the bottom, grams will go on the top. And 1 mole equals the mass of potassium, 39.1, times 2, plus the mass of sulfur, which is 32.07. So that's 110.27 grams. So to actually multiply this out, we'll take 3.3 times 110.27 divided by 1, and I get 363.89 grams of potassium sulfide. Number 8. How many moles are in 1.2 times 10 to the 3rd grams of ammonia NH3? So we're starting with 1.2 times 10 to the 3rd grams of NH3. And we're trying to find moles. So we're going to set up a conversion. We can go directly from grams to moles. 1 mole equals the mass of nitrogen, which is 14.01, plus the mass of hydrogen times 3. So that's going to be 17.03 grams. Now, in this case, we have something in scientific notation. You could expand this out as that would be 1,200 grams, or we can just put this in the calculator exactly as it's written. Now, to do scientific notation in our calculators, we're going to take 1.2, and then for times 10 to the power of, we're going to use this EE symbol. This is something that Texas Instruments brand calculators use. So to do that, we're going to use second, comma. That hits the EE button. So that brings up the letter E. The letter E means times 10 to the power of. So we don't need a multiplication sign. We don't need to use a little caret symbol. We just need to put the 3. And then we go on to the rest of the problem. Times 1 divided by 17.03 equals, and our answer is 70.46 moles. Problem number 9. This is about as simple as one can get. How many moles are in 9.8 grams of calcium? We're going from grams to moles. This is just an element. On the bottom, we put grams. On the top, we put moles. So our units of grams cancel. 1 mole equals the mass off the periodic table, 40.08 grams. So in the calculator, 9.8 times 1 over 40.08. And that equals 0.24 moles. Number 10, how many grams are in 238 moles of arsenic? So this is like problem 9 backwards. We're trying to go from moles to grams, where 1 mole equals 74.92 grams of arsenic. So in the calculator, 238 times 74.92 divided by 1 equals 17,830.96 grams. Yeah, that's a big number. Problem number 11. How many molecules are there in 2.3 grams of NH4SO2, ammonium? I'm not sure what that is. But anyhow, 2.3 grams of NH4SO2. Now in this case, once again, in our conversion, we're going to put grams on the bottom. Now this wants us to find molecules. We look back at our mole count up here. If we're starting in grams and trying to find molecules, which is a type of particle, we can't go straight from grams to particles. This is going to involve 2 conversion factors. In our first one, we're going to go from grams to moles. In our second, we're going to go from moles to molecules. So to go from grams to moles, 1 mole equals the mass of nitrogen plus the mass of hydrogen times 4 plus the mass of sulfur plus the mass of oxygen times 2. So that's 82.11 grams. And then the conversion between moles and particles, or moles and molecules, is that 1 mole is 6.022 times 10 to the 23rd molecules. So we'll put all this in our calculator at once. So 2.3 times 1 divided by 82.11 times 6.022 times 10 to the power of 23 divided by 1 equals, and that is 1.69. Now here's where you got to be careful. There is an E22. Now we're not going to write E22. We're going to write this like a normal chemistry or math student would write this, not using calculator notation, times 10 to the 22nd power. And our units will be molecules. Generally speaking, if you're trying to find molecules, your answer should be a huge number. For number 12, we're trying to find grams starting with molecules. 3.3 times 10 to the 23rd molecules of N2I6. In our first conversion, So now we're trying to go from molecules all the way over to grams. So we're going to put molecules on the bottom, moles on top. Those molecules was on the top here, so molecules goes on the bottom, moles goes on top. And our second conversion will take us from moles to grams. Now the relationship between molecules and moles is always the same. 1 mole is 6.022 times 10 to the 23rd molecules. The relationship between moles and grams, 1 mole equals the mass of nitrogen, 14.01, times 2 plus the mass of iodine, 126.90, times 6. So that's 789.42 grams. So now we just need to put all this in our calculator. 3.3 times 10 to the power of the 23rd times 1 divided by 6.022 times 10 to the power of 23rd times 789.42 divided by 1. And yes, I know you don't have to actually put the divided by 1 over here. And that equals 432.59 grams. Alright, now that I've done that much, I think you should be able to figure out the last few problems. Good luck.